So I'm going to walk you through a solution to the first free response that I was going to do for you. At any point in time, you are always welcome just to go to the College Board website and take a look at their solution. Just like with anything else in programming, there can be multiple solutions that satisfy all the programming requirements. So in other words, my code might look different than the solution provided from the College Board, but it doesn't mean it's wrong. It just means it's different. All right, so the first question involves a simulation of a frog hopping in a straight line. The frog attempts to hop to a goal within a specified number of hops. The simulation is encapsulated in the following frog simulation class, so you will write two of the methods in the class. So one thing that's true about AP free response questions is there's often a lot of reading involved. In fact, if I go to the end of this document, 4 free response questions from last year's exam took 18 pages. You are going to just have to get used to reading all the information before you start working on the program. So I'm given a frog simulation class. I have a piece of instance data called goal distance. It's the distance in inches from the starting point to the goal. I'm given another piece of instance data called max hops. It's an integer. It's the maximum number of hops allowed to reach the goal. Here we see a constructor. I'm sending it two integers. The first populates the goal distance and the second populates the maximum number of hops. Now, here is provided a method called hop distance. It returns an integer representing the distance in inches to be moved when the frog hops. This is going to vary. You're not given the code. You're not going to be asked to code this method. All you care about is the name of the method, what's required, which is nothing in this case. You care that it returns an integer, and you care what it does. Now, public Boolean simulate, it says to be implemented in part A. This is a method you will code. It returns true if the frog successfully reached or passed the goal during the simulation, and false otherwise. Finally, at the end of the first page is a method called run simulations that returns a double and takes an integer parameter. As it turns out, this is the number of times you run the simulation. So I'm going to flip the page. So part A asks you to write the simulate method, which simulates the frog attempting to hop in a straight line to a goal from the frog's starting position of 0 with a max number of hops. The method returns true if the frog successfully reaches the goal within the number of hops, otherwise the method returns false. So this reviews what you should be using for this question. The frog simulation provides a method called hop distance that returns an integer representing the distance. It could be positive or negative to be moved when the frog hops. A positive distance represents a move toward the goal. A negative distance represents a move away from the goal. The return distance may vary from call to call. Each time the frog hops, its position is adjusted by the value returned by a call to the hop distance method. So the frog is going to hop until one of the following conditions becomes true. The frog has reached or passed the goal, the frog has reached a negative position, or the frog has taken the maximum number of hops without reaching the goal. So here's some data that is given by the College Board so that you can see the result of running the simulation and what calls to hop distance will provide you. Notice that in this case, you never reached the hop distance. That's why this is, you never reached the goal distance. You only reached 18. That's why you didn't reach your goal. And here, you hopped, and you hopped again, but then you went negative. And as soon as you go negative, you return a false. In examples 1, 2, and 3, you keep hopping and you keep adding these numbers up until the number meets or exceeds 24, which is what we have in this case, and you were able to do that in 5 hops. Similarly, example 2, these add up to 25, exceeding the distance, and finally, the third one does as well. That's why we return true from simulate. Now at the bottom is a simple class diagram. Now this is not exactly what we did in class, but it's simplified. So it lists the name of the class, the instance data, and then the method headers that you will be using with the exception of the constructor. So part A is asking us to write the simulate method below. Be sure to use the exact method header that they give you. And you're also going to be referring to the instance data and this helper method called hop distance to code simulate. So I'm going to go ahead and start with writing my curly brackets. And I'm going to create a piece of data called hops. This is going to count how many times we have called the hop method, and we're going to increment as we go through a while loop. We're going to have another piece of data called total. That's an accumulator. In other words, that's going to accumulate what is returned from hop distance every time we call it. So we're going to want to compare hops to max hops, because according to our directions, we only have so many hops. We can be less than or equal to the max number of hops. So I'm actually going to use a while loop in this case. I'm going to say while hops is less than or equal to max hops. So as long as that's true, I will continue on. So let's say that that's false. So that means my hops exceeded max hops. I'm going to want to return false. So I'm going to write that down at the end so I don't forget. Now, so the first thing I need to do is I need to call hop distance, and I'm going to add that to our running total. So I'm going to say total plus equals hop distance. And remember, hop distance is going to return an integer. Now, recall that this can return a negative number. So at any point in time, I'm going to say if total is less than 0, then I'm done. I'm out. I'm going to return false because I did not reach my goal. Else, if my total is greater than or equal to the goal distance, that means I have reached or exceeded. I can say return true. Now, if this is not true and this is not true, that means I need to hop again. So what I'm going to do is I'm going to say, let's increment hops so we can take into account the number of times we've hopped. And then, we would go back up and we would check the condition again. As long as hops is less than or equal to max hops, I'll go inside and I'll hop again, calling hop distance and add it to total. I'll check my total. And if it's negative or greater than the goal distance, I'll return true. If I keep hopping and I exceed the max hops, I'll go ahead and return false.